some of you students, okay, are going to want to take some higher level science classes here. This is an introductory class, okay? When you get to the higher order of thinking, you are getting to biochemistry like this. Okay? This, okay, even though when we talk about a compound called heparin, it is a coagulant in your blood. So the structure for that is, I believe, this guy, even though he should be over there. Some people want to learn and understand this. And how do you set the stage for that? In this class. And when we got all these other sidebar conversations, you are not being very courteous to people who do want to understand this. Does that make sense? Okay. So then we go back to the central question, why do we do that? And I don't have an answer for that, but maybe you do. Okay. We're going to start classifying today. Okay, depending upon how far we can get. I guess, I don't know, I thought I might need that space. We'll see. Okay, so don't forget, tomorrow you have an evaluation in here. What are the large numbers called in a reaction? Those are called coefficients. What are the small numbers called?
I'm basically a professional at this.
What are the small numbers called then?
Subscripts.
Okay, so then when you put a charge on those, like -1, +3, those are not coefficients, they're not subscripts, they're oxidation states or superscripts, or exponents, you could say. Okay? All right, so moving forward, that's where we left off with. For those of you who decide to take a class like this in college, okay, we do our best to not only get you prepared at this level, for the high school level, and then hopefully the college level, okay? There's a lot of what we call complex chemistry that goes into this, okay? So I don't know if it really says that on here, but, oh, it does right here, okay? When it corrodes or rusts, what happens is that iron, it goes through a process of oxidation, okay? So if you go to a cleaning station for, let's say, cleaning fish, or I think at a campground is the best way to look at that. What type of tables would you have sitting out in the picnic shelter? Not steel tables. Wood, then it's, no, that's pretty close to aluminum, but too expensive. Well, iron, that's going to rust.
Copper. No, not copper. Cobalt.
It is a type of steel. That's just in the name only. Stainless steel, okay? So why utilize stainless steel outside?
It doesn't rust.
Because it's not going to rust, because that's why it's stainless. Because it's plated with nickel, could be aluminum, different types of alloys you treat that with that's not going to go through this process. Is it nickel what?
It's nickel made of nickel.
Oh, you're talking about the currency.
Yeah.
No, I do believe it could be such, there's a different alloy that's used, it's just nickel plated, okay? Which means it's just coated with nickel because it's just too expensive to utilize. That's why when you look at a quarter, okay, you got those ridges on there. Does anyone know why? There's two reasons. No. I suppose in the long run it'll cut back on costs. You can't see. You're reaching in your pocket. How do you know if you've got a nickel or a quarter? Okay, so luckily I didn't run into anything. Okay, I did. Oh, I probably hit the side of the table. But a nickel and a quarter are pretty close in size. You wouldn't be able to tell that by just having it in your hand. How does a blind person know that then? Yeah, there's ridges on there. Okay? Same with a dime and a penny. That's probably the secondary reason. But the primary reason is that quarters used to be composed of only silver. Okay?
What about a $1 bill and a $50 bill?
What? What are you talking about?
How does the blind person tell the difference?
You can't.
So then why do they have subscripts on them? Well, there's one that has like, why do they do it?
I don't know when it comes to paper money. Well, we're just talking about coins. Anyway, quarters prior to World War II, I believe, were all made out of silver. So what people would do is shave that silver off there and start collecting that and collecting more and collecting more. Now you got those ridges on there. You really can't do that anymore. Okay? But I do believe a lot of the currency is maybe made of a different alloy, but then it's just coated with nickel or coated with silver. All right. I think that could be, maybe it's not pure copper, but it's probably pretty pure. I really don't know, but I'm just going by what I think.
Start taking the ridges off the pennies? That's what Mr. D was telling us.
It costs more to make a penny than it's worth.
Yeah, I've heard that before too. Anyway, moving on. So, for probably, I'm going to say about the 5th time, and it's just going to be human nature. People are going to forget this. That.
O2?
Right, but what does that mean? Why is there a 2 there? I know there's 2 of them. It can't be by itself. It is diatomic. What is another diatomic element?
Hydrogen.
Hydrogen. What else? Okay, so those 3 elements that you just named, hydrogen, oxygen, nitrogen, what do they all have in common? I know they're all diatomic. What else? They're all gases. Gases are diatomic. What else is diatomic? Nope, helium's not diatomic. Why are you right? Yeah, where's it located on the table, though? Yeah, halogens are diatomic as well. Okay? Tells you that right here. Remember, gases are diatomic molecules, except for noble gases. Those are already stable. Why are noble gases so stable?
Their valence or their outer layer.
Yeah, it's in column 8, so its outer level is already full. Now, that doesn't take away from its chemical properties, okay? That being reactivity or flammability, because for those of you who have any type of tungsten inert gas or so when you hear tungsten inert gas, what does that mean to you? TIG welding. I don't know what the M is in MIG welding for sure, but when you do that inert gas, What inert gas do you suppose it is? I wouldn't expect you to know that, but there are some up there. Argon's probably the most common. That's why it says inert gas, because it doesn't react chemically, but its property, it is very flammable. Okay? Inert tungsten's probably that goes through there. The inert gas is probably the argon. You add the spark and the heat and the electricity, it reacts with one another, and that's how you weld. Okay? Okay? So, when you got a balanced chemical equation, all of the elements on one side will balance with everything on the other side with the use of coefficients. So just by looking at this, okay, you've got 2 oxygens over there. How do you get 2 over here? Put a coefficient of a 2 here. Now your oxygens are balanced, but you got 2 mercuries. And you just put a 2 here. Okay? Okay? And some of you have experienced this. Sometimes it just takes trial and error. Okay? And that trial and error can be anything with science. It could be we're going to experiment on, for some of you who maybe do the long jump, the high jump, the hurdles. Okay? Or maybe you do trial and error in your 4x1, 4x2. Who's going to be the start of the race? Who's going to be the last one? Who do you put in the middle? Now, one of the major reasons that you would constantly, let's say, flip-flop who's running first and who's running second, especially in the 4x1. Because if it is very windy, for some people, it may not make a difference if they're running into the wind or not. Okay? If someone has a smaller frame to them, you probably want the wind to their back. Someone with a larger frame is probably going to be very similar in speed, whether they're running into the wind or the wind is behind them. So you may experiment by just trial and error. Okay. And also don't forget, you have another assignment that's due tomorrow. Your vocabulary. Okay. And you're all, whether it's this class or any other class, or even when you said, what does T stand for? That is another part of vocabulary, tungsten inert gas. You're going to be using vocabulary in your job, whether it's mechanical related, whether it is a medical related, or even if it's agriculturally related. Okay? In other words, what does PTO mean? It's not paid time off. Some people might say it's paid time off. It's power takeoff. Those are just some different types of examples that vocabulary is just a way for you to explain one concept from one person to another. Okay, I just want to do one more. I just want to see, what does this one look like? Okay, we'll get into section 3 tomorrow. We're going to show you some examples of classifying these. We'll just do it that are on your paper already. Does everyone have this information that wants it? Again, what it's doing is helping me explain this content to you. So again, this is just explaining everything about mercuric 2 oxide when it decomposes into its separate parts. Okay? So what do you suppose that means when something decomposes? Whether it's a chemical reaction or sort of breaks down. That's a better way of. So when you see a carcass on the side of the road, okay, there's a farmer north of Del Rapids on Old 77, and probably going through the calving season soon. When a farmer loses their cattle, they just for some reason get sick. How do those get hauled away? The rendering truck. Okay? So what happens is, why is there no rush to get rid of, unfortunately, cattle that don't make it now as opposed to cattle in June? Because they're going to rot a lot faster. When it gets cold at night, okay? Well, they freeze, but just like you preserve food after having leftovers, because if you leave them out, bacteria is going to start to accumulate and starts to break things down. Same thing with carcasses. When it's cold like this, and then at night, Mother Nature's got its own refrigerator. So it just does not start to break down, unlike in May, June, July, August, and all the way up until you get your first cold temperatures. Okay, does everyone have this that wants it? Okay, so
What's the rendering truck gonna do with the carcass after that normally?
I don't know. I mean, where do they go?
Make Burger King.
I don't know.
Burger King.
I don't know. Probably fertilizer more than anything else. Okay, so
Wait, so you chop up your cows and then just fertilize them?
maybe. I don't know.
Kind of like dog food plant.
Okay, so if this was to go through this process of decomposition, you correctly said that when things break apart, that's another way of saying decomposing or decomposition. So what you'd want to do first, what is iron 3 oxide? What is the formula? What is iron?
Fe.
Okay, what is oxide?
O2.
Okay, what is the charge of oxygen?
Negative 2.
What can iron have for a charge?
Negative 2.
No. Or, so we're not guessing here. We're telling you that right here. What is the least common multiple between them, okay?
2 iron and 3 oxide.
So, if this is going to decompose, that means it's breaking apart. That's what you had said earlier. So, how does that break apart or decompose? How? Between the ions. Okay, you can do that. What else is part of iron 3 oxide? Iron itself. Okay, now, subscripts do not automatically go to the other side unless it's a polyatomic ion. Give me an example of a polyatomic ion. No. There's one.
Maybe if that's our treatment, I need probably does.
Well, OH, it doesn't have any subscripts though. We'll just use one more. Okay, now, I guarantee you, if you don't, it just makes it that much more difficult when you don't catch this the first time around. Some people don't, but if we're just goofing around, then you just make it more difficult for yourself and everybody else. There is that selfishness again. Okay? So these subscripts are part of the formula. Okay? You might say, well, these subscripts, they're not part of the formula. They are just utilized to balance out the compound. Okay? So what that means is that's when you find your least common multiple, and then you put those subscripts down below. How many of you would look at this and say that? Does anyone think that's correct? Good. No one raised their hand. Either that or we just didn't want to. Okay? Because these were just utilized to balance out the compound. So,
The oxygen is a diatomic.
why is that? You're right. Why is that so important?
Because it's diatomic.
So what does that tell you need here? Okay. Iron is just a metal. It's not a gas. It's not diatomic. So when it's by itself, you just leave it as iron. Just like you would sodium, aluminum, nickel. If it's by itself, it doesn't have a charge. Okay? So now, just by trial and error, some of you are probably getting pretty good at this. Iron's left.
2,
Iron's right.
1,
Oxygen's left. Oxygen's right.
2.
Okay? So how would you go about balancing this?
6 in front of. Wait, no. Never mind. Sorry.
What?
Okay? That needs to be distributed through the entire compound. What's 2 times 2?
4,
Okay? What's 2 times 3?
6.
Okay?
And then put a 3 in front of the O. 6. And then a 4 in front of the S.
Okay, it's now balanced. Okay? So, let's go ahead and I just want to do one more example, and I'm going
Yeah,
to,
can we do a little bit like 100?
that's what I'm getting at. Okay, because the more exposure you have to this, the better off you're going to be in the long run. Okay, so if we did this, okay, give me a alkaline earth metal.
Calcium.
Okay, so this is not a gas. It's by itself. Does that need to have a subscript? Why are you right when you're shaking your head no? Because it's not diatomic. That's right. So, are any of these subscripts going over there for sure?
No.
Yes.
Oh yeah, SO4.
Why is this one going over there for sure?
Because it's sulfate.
Because it's part of the formula. Okay? So once you do that, okay, we've got calcium and SO4. Because remember, we put that in a box. That has to go over there. Then, well, that too, that must go over there because it's over here. Okay. You're getting it right, but for the wrong reasons. Okay? Because if you just write hydrogen over here, why would that be wrong? Because it's diatomic. Okay? So you still have to put a 2 there anyway. Just know that it's diatomic. Don't put it over there just because it's over here.
How do you know if it's diatomic?
Because it's either a gas or a halogen. Yes. Okay? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, because those are halogens. Okay. Now, who wants to balance that? It's already balanced. You don't have to change anything. Okay? This is a single replacement reaction. Okay? The reason this is your clue, this metal is all by itself. Okay? So it's kind of like with the prom season coming up, or maybe at a middle school dance or something to that effect. Someone is sitting here all by themselves. Okay? then they choose to go in or ask someone else to dance. So the ion gets split apart here. This is +1, that's -2. The charges don't change, so this has replaced that hydrogen. So there's the R for replacements. And since calcium is by itself, it's single. Okay? That's why that comes as single replacement. So what did calcium replace in this compound but on that side?
Salt.
The hydrogen. Whoever said the H, you're right. That's a single replacement reaction. We're going to talk about this a lot more. We're not just going to go through one example of each and say, well, if you don't get it, that's your problem. We could, but I don't think that's the right way to do it. But sometimes I think you just force us to do that and then just let the cards fall where they may.
When will our next test be?
Tomorrow?
Probably somewhere in the March 24, 25. That's just a total guess. I would think perhaps the 16th. That's a week from today. There's not just one problem quiz. There's probably either 2 or 4. I don't know yet. Okay? Wednesday? Monday. Okay. But that's where we'll stop for today. This is difficult stuff. Okay? But some of you, how many of you like this better than the mathematics in last semester?
Last semester I liked
3, 4, 5? Depends on the day. So how's today then? Yet. Not yet. Okay, so barring no questions, we'll stop there. We'll catch up to you next time.